Hello guys, this is Jacob. Today we're gonna do a video on how to fine-tune your large language model for your specific usage case, and we'll also follow up to see if this actually works. So a lot of people talk about fine-tune models, and so that the model basically can perform for a specific usage case like your business and your specific project. So one of the tools that's very popular today on the market is called onSloth. So meaning that it's gonna fine tune a model and make it perform fast. So I think that's what they call onSloth. So if you go to the onSloth GitHub, here's the repo, and so they also provide all the notebooks, so you can actually try them all out to fine-tune a large language model, which is open source large language model, like Llama 3.0 and also like G-Minor v3 and Mistral, so on and so forth. So let's open up the Llama 3.1. All right. So this is actually just use the onSloth framework and fine-tune a Llama 3.1 8B model, because notebooks are resource limited, so you cannot really fine tune a 70B or 405B. 8B is fine. So let's go through the notebooks to see how they actually do the fine tuning. First, have to, of course, install the dependencies, and then after that, basically, these are all the 4-bit models for onSloth. It has Llama models, it has Mistral models, so on and so forth. And then basically they're gonna use a fast language model, which is from onSloth, to load a pre-trained model. In this case, would be Llama 3.0. So actually load the model and the tokenizer for that model. After that, basically we'll get the PEFT model, which stands for parameter efficient fine-tuning models. So you can see actually they pass in a bunch of params, and then they basically got the model, which is essentially a LoRa adapters. So these are basically to add adapter for fine-tuning. So you have a model, and then you add adapter on top of the model, which trigger a lot less parameters for that model. So basically have the fine-tuning going on. After that, you basically just do a data set, right? So load the data set. After the model is ready, let's load a data set. So basically, you load the data set from, basically you can grab it from Hugging Face. So here's the Llama alpaca. This is actually from, remember it's from the Stanford. So you can see all the data is very generic, right? So this is the output, and here's the input, and also basically these are the instructions, right? Let's go back to the notebook. So after you load the data set, then you basically load the model and tokenizer and the data set into the supervised fine-tuning trainer, which is basically the trainer that you're gonna run later on to fine-tune that specific model, which is Llama 3 in this case. And the next section, which is the notebook block, is just trainer.train. So you will have the trainer and then start training. So you basically get all these training laws here. So you can actually see that this basically use the max steps of 60 and a batch size of 2. Right. So then you got all these different steps going on. You see the training loss is getting less and less. So after 60 steps, your fine-tuning is done. You can also try, I think it also provides some of the memory stats during the training. And after the training is done, so you have your fine-tuned model. As simple as that. And you can just try their notebooks to actually pass in some of the params, basically the prompts. So then you can actually, they already actually logged everything here. So we'll not run in this video, but you can try them out. So basically you got an input, and then you left output as blank, then they will actually give you the output. Right? So give you the output from your input. So if you look at the 1, 1, 2, 3, 5, 8, which is the Fibonacci sequence, what's the next one? Right? Continue with that, and then it will give you that the output, which is 13, 21, 34, 55, blah blah. Right. So this is actually the next Fibonacci sequence. So the next test, I think it's just a very similar one. Right. So then let's see. Okay, yes, actually I think this is a streaming case. So you actually got the streamer when you do the output. So you get the input and then you got the output. Right. Then after you test all these input and output, see if they actually respond correctly, then what it will do is trying to save the model. They have a lot of the sample here, right? They actually can save the model locally. Also, if you want to save the I believe this is the adapter. I think one of the lower adapter. If you want to actually save the adapter, you can also save the adapter, but you want to also save the model. You're basically doing very similar things. So in this case, you will probably want to save the model. You want to save it local or remotely because it's a notebook. You probably want to save that remotely. So in this case, this is actually the LoRa, just LoRa adapter, so you can actually save the LoRa adapter. You also want to also probably save the actual model in here, right? Save the model. You can save it using different bits, like 8 bits, 16 bits, and 4-bit. And then you can actually just comment that out to see, set it to true. Then it will actually push the model to Hugging Face. There's some confusion when I put the lines in here. The reason is you actually push to Hugging Face. It's actually going to save locally first. So so you basically can just push the Hugging Face. That's it. So you don't have to run every single line. Just save space, because if you actually run every single line, it will consume and take a lot of resources and disk space. So you will not actually run everything on a single notebook on Collab, because Collab is actually very restricted on resources, and not just GPU but also some space. So you definitely want to actually only do maybe one of the lines. You want to probably save it in the Hugging Face, then you can actually use later. And if you want to save them all together, you can do that as well. Just do the quantization method as all of them. So basically this is actually save multiple options, right? So and that's it. That's actually how you can actually take a existing open source large language model and then add your fine-tune data for fine-tuning, and then to basically attach LoRa adapter and start training with those data, and then you get your fine-tuned model and then save the model. So that's all very straightforward. So the issue with the fine-tuning actually is that if you look at all the data that's actually used to fine-tuning, they're not usage case specific, right? They're actually very generic. So then the fine-tune actually is not exactly the way that people think that's gonna be very specific for a usage case. If the usage case is very generic, that would work. But if you, let's say, you want to fine-tune something for a ABC project or ABC company with a lot of URLs and with a lot of links in it, it probably will not work. The reason is that the model is actually based on tokenizer. So think about like all the links and all the the URLs inside a training set. It's gonna be tokenized. So then when you actually ask a question later on, that wouldn't exactly output a URL you want to be output. So the fine-tuning really doesn't work exactly as a very specific case for a specific project or specific business, but it's still very generic. So that's what fine-tune is. It's still very generic. And also, that's one thing. If you want to make the fine-tuning more robust, or maybe you want to see how many time it took, how many resources it took, and how many GPU time you can use, Colab might not be exactly the environment you want to use, because you can see that Colab, they don't have a timer. So if you actually train on a notebook, it doesn't give you how much time you have left. Let's say how much time or how much time you have been given for training for this month or this week, right? So in this case, you probably want to consider Kaggle. So for example, this is actually the same notebook for this one, but it's running on Kaggle. So the good thing about Kaggle is it actually gives you the time you're gonna be able to use for a week. So for example, if you actually go to the code section, you want to go to this section, you can see actually there are 30 hours for this week. So it's actually 1 week for 30 hours, then you can actually got a refresher another 30 hours, so you get another 30 hours for the following week. So which is actually better if you want to monitor your training time comparing to the Colab. By the way, so Colab and Kaggle are both now part of Google, but Colab is a lot older. I think it's very early developed, so it goes back in years. So, but Kaggle is a little bit newer, and I think it's modern. I think it's more modern. And then if you use Kaggle, you get better UI, you got better timer. You can see how many time you have. But one thing is when you use Colab, you don't need a phone verification. You don't need a phone verification. Actually, use the GPU. But on Kaggle, you do need a phone verification to use the GPU resource. I think yeah, that's kind of summarize this video. So we went through the Onslaught framework. So this is how you actually fine-tune your open source model. This seems to be one of the easiest way to actually fine-tune a model, and it's great because it actually performs awesome, and it has less memory usage. And also they provide good notebooks so you can actually see how it is and training, and also we covered which one is better, Google's Colab or Google's Kaggle for your fine-tuning. Hopefully this is helpful if you want to fine-tune a model, and if you do like this video, please comment, and if you have any questions, and if you really enjoyed it, please subscribe or like it. Thank you so much. See you in the next one.